Okay, let's take a look at 2.1 part 2. Okay, so let's set up some flashcards and do a review of what we did in part 1. So this is just one flashcard and it's each side. So on the first side, you're going to write a little problem here. We've got the class is 6 through 10. In other words, my lower limit is 6, my upper limit is 10, and I want every person who has a score between 6 and 10, including 6 and 10. And we're asking what is the midpoint. So this is your first side of your card. On the other side, we're going to first have the definition for the midpoint. So that would be the lower limit plus the upper limit divided by 2. The midpoint is an average. We want to know the number that's in the middle of 6 and 10. So we take 6 plus 10 divided by 2, and that gives us 8, and that would be the midpoint. All right, so here's something new. We're going to work on this in this. I think we have problems in this one. If not, it's going to be in part 3. So we have a bunch of data. The maximum piece of data is 2,297. So that's the largest piece of data we have in all of this data. The minimum, or the smallest number, is 1,250. Okay, so that's my largest number and my smallest number. And I want 8 classes. Okay, so I'm going to have 8 rows in my frequency distribution. So I want to know, what is the class width? Okay, so this is also on your resource sheet, but what happens is we need the range divided by the number of classes. This is why it's important that they have to tell us how many classes they want or set it up for us. So the range, we did a little bit in part 1. The range, we're going to take the maximum point minus the minimum point. So for us, that's going to be 2,297 minus 1,250. That's the range. So the largest data point minus the smallest data point, the max minus the min. And then we're going to divide by the number of classes. They told us they wanted 8. So in this case, if you put that in your calculator, you get 130.87. Now, we don't want our class widths, for this class, we don't want our class widths to have any decimals. We're going to do whole numbers, but we're also going to always round up. Now, this one naturally rounds up to 131, but even if this had been 130.17, we are still going to round up for class width, because otherwise we'll get to the bottom of our intervals or our classes, and we won't be able to include all of our data because we'll have a round off error there. So always, we're going to round up. I think I have an example of that. Yep, here we go. So another one here, a flashcard. Our maximum data point is 99. Our minimum is 13. So my largest piece of data is 99. My smallest piece of data is 13. And this time I want 5 classes. And it says, what is the class width? So again, I want the range over the number of classes. So the range is the max minus the min. So that would be 99 minus 13 divided by 5, because that's how many classes I have. Now, when I put that in the calculator, I get 17.2. Now, I know that normally we would round down to 17, but there's 2 times in this class that we are going to round up, and this is one of them with class width. So we're going to go ahead and round that up to 18. Otherwise, we're not going to have enough room when we get to the bottom of the classes. So always, we're going to round up, even though it doesn't look like we should round up here. All right, let's practice relative frequency. So again, I have this set up as a flashcard if you want. It just gives you a quick look at how you would do relative frequencies. So on this side, I have a small frequency distribution. I have classes of 1, 2, 3. I have my frequencies, and I asked you to find the relative frequency. So the relative frequency, we're always going to have decimals. These are actually percents. So over here, what I did was I can't compute the relative frequency until I know the total of the frequencies. So this sigma, I'm not sure we've looked at that yet. That means sum, and that means we're just going to add up all the frequencies. Okay, it is a capital sigma. It's a Greek letter, and it just means to add everything up. So if we add 10 and 13 and 5, we get 28. That's our total. Because remember, relative frequency has to be the piece over the total. All right, so on the first row, we have 10 is our frequency. So we're going to put 10 divided by our total of 28, and that gives us 0.36. For the next one, we have 13 as our frequency. So we're going to put 13 divided by 28. That gives me 0.46. And finally, we have a frequency of 5. So 5 divided by 28 gives me 0.18. So this, if I change this to percents, which we know how to do, we're just going to move the decimal over, you would see that the first class makes up 36% of this data. The second group makes up 46% of the data. And finally, the last group makes up 18% of the data. And if you add those all up, you'll get to 100. All right, this one's a little different, so you have to watch. I have the same data, but this time we want the cumulative frequency. So remember, the cumulative frequency is going to be whatever row you're on plus any of the rows before. So when I'm on this first row, I only have the 10. I don't have anything before, so my cumulative frequency is 10. When I come here to the second row, I have to include the 13 that's sitting here and the 10 before it. And so that would give me a cumulative frequency of 23. And then finally, when I come to the third row, I'm going to take the 5 plus the 13 plus the 10, which gives me the 28. And sure enough, I know that my sample size from the last flashcard was 28. And so that's a good check. You want to make sure that when you come all the way down your column of cumulative frequencies, that you end up with the sample size at the end. So remember, that one is the sample size, and we use the letter N to denote that. Okay, so now we're going to get a little trickier here. They gave me a class width, and they gave me the first class. They told me my lower limit was 1, my upper limit was 15. They told me the class width was also 15. Just that's a fluke. And they want me to fill in the boxes. So for this, we haven't really done a problem with this yet because the classes were already set up for us. We have to work our way down. So I did talk about it a little bit. We're going to start with the 1. We're going to start with the lower limit here. We're going to add the class width of 15 to that 1. So if I add 15, I get to 16. If I add 15 again, I get to 31. This is how we're going to make these classes. On the other side, we started with 15. If I add the class width of 15, I get to 30. If I add class width of 15 again, I get to the 45. So we're just going to add 15 all the way down. We'll do some examples in a little bit. All right, so this slide's from the book. Let's see if we've missed anything. We have to know how many classes. With us, the problems are going to tell us how many classes. We have to find the class width, so we know how to do that. We've been practicing. We're going to take the range of the data. We're going to divide by the number of classes and then always round up. Then we have to work on our class limits. So if they don't give you the very first one, it's going to be your smallest data entry. And we're going to do one of those in just a minute. And then we're going to put all of our classes together by adding the class width all the way down. And then finally, we have to look at our data and we have to figure out which class our data fits into. And then we're going to use those tally marks to figure out the frequency for each of our classes, for each row. All right, so let's look at this one. It tells me that my minimum data point is 7, okay? And then it tells me that the maximum data point is 77, okay? And that's given to me up here. And we want 6 classes. So the first thing we have to find is the width. Okay, so remember the width, we're going to find the range, which is the max minus the min divided by the number of classes. So let me see what I get for that. Looks like we have 70 divided by 6, which is 11.6666. So we're going to round up to 12. That one naturally rounds up, but that's my class width. Okay, so now we're going to figure out our 6 classes. So when we do this, we're going to start by the smallest data point. So our smallest, let's go ahead and do this. 1, 2, 3, 4, 5, 6. And I'm going to make lines here. Okay, so our minimum point is 7. Right, that's going to be our first class. And to find, this is our lower limit, we're going to work our way down by adding 12 every time. So if I add 12 to 7, I get 19. If I add 12, whoops, that's not right. If I add 12 again, I get 31. If I add 12 again, I get 43, 12 again, 55, and 12 again, 67. Okay, so those are my lower limits. Okay, now I have to find my upper limits. Let's change color. Now we have to find the first one, right? So what we do is we look at, let's look at this one. We're going to look at the lower limit on the second one. That's 19. That means I want the number right before that, because remember, we can't have overlap. So if I have 19 as my next number, then 18 would have to go here as my upper limit. Hopefully that makes sense, but we'll look at some more. Okay, and now I can start doing the same thing. I can add 12 every time, right? I'm adding the class width. So if I add 12, I get 30, add 12 more, and keep going. All right. So let's see what this problem wants. So after all that, my classes are put together here now. I'm going to put a line through here. So remember that this first group, this first column are my lower class limits. So I have 7, 19, 31, 43, looks like D. And then over here is going to be my upper class limits. So I have 18, 30, 42, looks like C. All right, so we'll do more of these. Don't worry. All right, so here we go. Let's work our way through this. So they gave me a bunch of data. These are 20 male participants in a 5K race. It's their finishing time in seconds, and they want 8 classes. So the very first thing we need to do is find our minimum and our maximum. So if you look through this data, it looks like the largest data point is 2296. And then the smallest data point is 1,251. We're going to divide by the number of classes, which is 8. And remember, we always round up. And so this is our width. That gives me 131. All right, so now we're going to fill in this table. So we always start with the smallest number. So our smallest number was 1,251. And what we're going to do is add 131 all the way down. So if I take 1,251 plus 131, that would give me 1,382. And then I'm going to keep going. Okay, so this is my lower class limit. I started with 1,251. That was my minimum point. I added 131 all the way down, and I finished up my lower class limit. Now I have to start the upper class limit. So for this one, I can't add 131 across. That's not going to work, because if I add 131 across, I would get 1,382, and I already have that on the second level. So what we're going to do instead is we're going to look at the second class that has 1,382, and I'm going to take one less, right? Because we cannot have any overlap, but we don't want to not include someone either. So we're going to take that 1,382, subtract 1, and that will give me 1,381. Now I can do the same thing. Now I can add 131 all the way down. So 1,381 plus 131 would give me 1,512. And I'm going to keep going. Okay, so I kept adding 131 all the way down, and it's kind of messy. I can't fit in those little boxes, but you can see that now I have my classes. So now I have to figure out my frequency. All right, so I'm going to do tally marks over here on the side. So for the first one, I need all of the data points that are between 1,251 and 1,381. So let's take a look. So I'm going to work down the rows. I've got 17, 14, 19, 18. That won't work. There's one. 1251. That's one. 15, 20, 15. I don't. Oh, 1304. Okay, so I have two. I have to change these. I have two data points that fit between 1,251 and 1,381. They can include those endpoints, but they have to either be on the endpoints or be in between. Okay, let's try the next one. So the next one is between 1,382 and 1,512. So let's see. I've got 1447. 1523 won't work. I have 1474. And 1479. All right, so that gives me 3 here. And then let's do one more together, but then I'm going to finish up from there. So now I need from between 1,513 and 1,643. Okay, so let's see, 1631, 1523, 1573, 1596, 1619, and 1579. Okay, so notice as I went along, after I got to 4 tick marks, I would put a line through so that I knew I was at 5. And so there were actually 6 numbers that fit between 1,513 and 1,643. All right, so hopefully I tallied all these up correctly. So on our frequencies, we have 2, 3, 6, 1, 4, 2, 1, and 1. I went ahead and added those up to make sure they added to the 20 data points that I should have. And then we could get to work with the relative frequency and the cumulative frequency. So let's do the cumulative first. So remember, that's going to be the row we're on plus any above. So for the first row, we're only on that row. So we're going to have 2. On the second row, we have the 3 from there plus the 2 above. Oops, that's 5. Then we have 6 plus 3 plus 2. That gives me 11, and so on. I'm just going to keep adding as I go along here. Every time we go to a new row, and I should get to the 20, right? That's what I'm supposed to do. So each time, like if I looked at, let's say I looked at row 5 would be 4 plus all of the numbers before that. So that would get me to 16 if I added all those numbers up. Okay, so the relative frequency, I'm not going to do all of these for you. This video is getting pretty long, but let's do the first one. So remember, relative frequency has to be the piece over the part. So we've got, for the first class, we have a frequency of 2 over the total of 20. So that's going to give me 0.1. We'll do one more. For the second one, it would be 3 over 20. So that would give me 0.15. All right, and then you would keep filling out that table. Okay, so I went ahead and filled in the frequencies for you. If we change those to percents, we have 10%, 15%, 30%, 5%, 20%, and so on. So remember, these show us what percent each class is of the total. And the way we find that is take the frequency over the sample size. All right, I just wanted to go over finding the class width one more time with you. We looked at our data and we found that our minimum point was 1,251. The maximum point was 2,296. This is important because we have to find the range. So that's the smallest number and the largest number in the data. The problem told me they wanted 8 classes. So what I have to do is take that largest number minus the smallest number, and I'm going to divide by the number of classes. So that gives me 130.625. So this naturally rounds up to the 131. For class width, we don't want decimals. We want a whole number. But we always round up. So even if this had been 130.225, we would still round up to make sure that we cover all of our data in all of the classes.